moving on to a new topic area, we're moving into the shape modules, and this week we're going to be looking at circles. Circles all around us, and I'd like you to go and get some examples, and we're actually going to do an investigation. It's the earliest point that circles got dealt with was to find out what was the relationship between the outside, the circumference, and a measurement that we could make of the circle. Now, if you've looked at the Pi Day stuff, I put a note in there saying I believe we should be basing it on the radius. Unfortunately, it's hard to measure radii. So what people did was they started off by measuring diameters, going right across the circle, through the middle and out the other side. So that's one of the measurements I'd like you to take. The other one is to actually measure the distance around the outside of the circle. We're going to record the information, and we're going to record it in a table for your book, but we're also going to make some copies of some of the circles, and I'd like the information put on those as well. You'll see in some later videos that I'll put, make a tracing of a circle, I'll do all the measurements on it, and we'll do some calculations with them as well. The aim is those ones will lead towards some form of display that you can make, preferably get them photographs sent to us if you can do it in different colours. So you need to collect the load of objects that are circular, things like bicycle wheels, if you can get a measurement on a tyre. Big things are good. It often means that you can get a more accurate value. So what we need to record is what the object is. We need to be able to measure the circumference, and in a minute I'll show you how to do that. Now, at some point you might actually measure them in different units. I'm just going to measure in centimetres and record in the table. Will go on about inches if you have them available. They might allow us to get some more data to check with. So the circumference is the distance all the way around the circle, and I want to know the diameter. Do leave some space on the right hand side, because what we're going to come back is we're going to estimate the ratio. It's only an estimate because these answers are not going to be the same. What do I mean by a ratio? It's do a division. So we're going to divide the circumference by the diameter. You've probably done stuff like this before, but there's no harm in us reconnecting to it and re-emphasizing what's the definition of this value you're going to work out. I think most of you know what that is. Okay, so off you go. Go and get your stuff together. Continue watching the video and see me making some measurements, and we'll come back and put some values into my table, and we'll see what happens with this estimated ratio, the ratio between the circumference and the diameter of a circle. Okay, from the title you probably know, we're talking about circles. There's an example of a circle, my coffee cup. Now, what we're going to do is think about what things we can do to measure them. What measurements can we take of just the circle part? We're not worried about them being a cylinder or something a bit more like a ball shape. What we're interested in is the circle it shows around the outside. So what we're going to do is I'm going to show you loads of circles that I've found. I want you to go around and find as many different circles as you can in your house. The sorts of things I'm talking about: cups, toys, pins. So I can actually do the top, I can do the middle, I can even do the base. So there's a number of different places you can do. Don't just think about one measurement. My alarm clock, the thing that got me up this morning. Yeah, I could do this and do the measurements on that. Find out the circle. What we're looking to try and do is work out how can we say how big is the distance around the outside of the circle compared to something else we can measure. And there's two measurements that can be linked to the circle. There's the diameter, the distance across, and the radius, which is the distance from the centre to the outside. Now, if you actually had a look at the Pi Day videos I put up, I strongly believe that the measurement should be based upon center to circumference. Unfortunately, that's a bit hard to do. So historically, we work upon using the value based upon the distance across a circle. Now, hopefully at the end of this session, you'll find out all circles are similar. If you stretch it one way, all the measurements to do with it should stretch by the same amount, and it's how are these numbers linked? That's what we're looking for. So I suggest you get a few objects you can actually do the measurements with. I've even been outside because I'm able to. I've got paint cans outside, I've got cars. I've got quite a selection of things around. This one might be fun. The Roomba, cleaning up the floor cleaner. You can go into the food cabinet. I've got my pot of mustard. The peas, nice can for peas. Unfortunately, Christian got to the popcorn. I haven't got any popcorn left, but the pot, it's a nice circular measure. Rolls of tape, a couple of nice circles there. Plastic cups. These ones are probably, I wouldn't trust the answers for these, but it might be worth trying, is to do things like a cap to a bottle. I've got a washer, so I could actually try doing the measurements on that. Not anything else quickly. Outside I found bicycle tyres, car tyres. So I'm just going to take you through how we can measure the circumference and the diameter. So I'm going to create a list recording circumference and diameter. I think I'm going to do it probably with the toy, because there's a couple of things to consider with this. I want to know how far is it all the way around, and I also want to know how far is it across. Now I will use a tape measure. I suggest you get a cloth one if you can. I've only got one of these work tool ones. These aren't particularly good because they're not designed to bend. They're actually designed to stay flat. So I'm going to use this to take my final measurement. So I'll do the distance across there, and that's where I'm going to be measuring from. If you have a tool like this, you might find there's actually two scales. We've got the centimetre scale, and you'll have, if you've got Fs and either dashes or double dashes, you've also got an inches scale as well. Take both if you can. We want as much data as possible when we come through, so that when we do the calculations, we've got as much as possible. So I'm just going to show you how I'd go about measuring something like this. And the tool I need is some string. I need the string, something nice and flexible. If you haven't got string about, you can take some paper, cut strips, tape them together. Just make sure you keep it reasonably straight along the edge. And you can use that to make a long tape that you can wrap around, make a little mark, and know how long it is. So I'll just get some of this out of the way. Sorry, I was supposed to be pausing. So I've just cleared the space. It's worth working with clear space. So I'm going to use string to do mine. Black string. It's nice and dark so you can see what's going on. And I want to measure the distance all the way around. So I'm going to start near that button and lay the string round, following the seam as accurately as I can. When I come back to the start here, I need to know where the join is. So that's where my thumb is at the moment, and I've got it locked down. So lock the end down so I can actually measure my circumference. So with a tape measure like this, take it to the nub at the end, make sure the end of your string's on there. Push the tab in if you're measuring like something like this. These things are designed to measure both inside and outside distances, and we're going to measure an outside distance. And if I go along to here, I can read that off. In inches, I've got almost exactly 21 inches. In centimetres, that comes down to 53.3. So I'm going to make a quick note of those two distances on the table that I've shown in the earlier part of the video. There we go. So 21 inches and 53.3 centimetres. I'll show that in the end on my table. The other thing I need to measure on this is the distance across it. Distance across three-dimensional objects like balls and these, it might be beneficial if you can get a couple of boxes. If you put a box across the top and try and make sure they're pointing at each other, everything's nicely lined up. Helps if the box stands up. Let's turn that one. So I want to go across the plastic, line it up, and I could either use the tape measure and measure the distance in between, or again I could use the string if it's accurate. It is beneficial when you try and do these if you can make sure you've got a nice straight, something straight that you can measure against. So I'm using two insides of the boxes. I'm not advertising them, we don't use them anymore. Oh, sorry, I forgot to take a measurement. So I've got across, check them across the longest distance, make sure the boxes are lined up. In fact, let's put the tape measure along it and make sure they're all lined up. And then measure the inside distance on the top. And if I slide this forward, hopefully you can see what I'm doing a bit clearer. So there we are. Hopefully they're nicely lined up. You might not see them as lined up at the moment because of the way the camera works this close. But if I put the measurement down, I have a distance of 6.5 inches on that scale and 17 centimetres. The object was a nightlight. I measured its circumference at being 53.3 and its radius is 8.6. Oh, sorry, don't want radius, I want the circumference. Circumference was 17 centimetres. Sorry, radius is for another lesson. Take a calculator and do the division, and we get 53.3 divided by 17. Gives me, we only need two significant figures, and I get 3.14. That's incredibly lucky. I'll go off and do a few more objects and come back to you in a few minutes. Okay, so I've gone off and measured some objects of my own. I've got a dartboard, a mug, Roomba. I could have done loads more. You've seen the sorts of things I managed to find around. So we just need to calculate these ratios. So I'm going to grab my calculator and we will calculate what is this ratio. You probably guessed from the top one we had a good number there. I've got 132.1 divided by 42, and that gives me another good number, 3.15. Notice I had to round up that last digit. I'll show you again when I bring it back. So notice I want two decimal places, 3.14. Look at the next digit, the 5 rounds it up, so it's 3.15. Let's try 24. That doesn't do it. 24.8 divided by 8, and that gives me an answer almost exactly 3.1. So 3.10. And my Roomba is 96 divided by 30, and that's going to be 3.2ish, I think. Yeah. 3.20. So we're getting numbers a little bit bigger than 3. Tomorrow I'm going to set some tasks using my iMaths to do calculations. You'll have access to their video. Tomorrow you have a look at this video. You've actually done the exercise number 2 if you've actually done what we've been talking about properly. but what it shows is if you rotate a circle along its circumference and then compare that to the diameter, you get ever so slightly above 3. And yeah, you've all been around enough to know there is a special number called pi, and it's 3.14159 to 6 significant figures. Those figures would be accurate enough for you to measure the circumference of the Earth in meters to the nearest whole meter. And if you know anything about the Earth, it is remarkably smooth compared to a billiard ball, but at that accuracy, I would actually be able to detect the differences in going around the equator and going north-south and realizing that it's not completely circular in all directions. So hopefully you'll do this exercise properly. It's an experience. If you don't do this experience stuff and you think you just learn things by rote, it often means that a little bit of the understanding disappears. So please do try these exercises, collect these things. If nothing else, the practical exercise of being able to measure circumferences and diameters of circles, it takes a bit of thought. So that's it for this lesson, is this measure, and we're coming down to the value that you should all remember, which is to the nearest 3.14159. So to 6 significant figures, 3.1459, it does continue forever. It's a number called transcendental. It's part called pi, and it's represented with the Greek letter P, same as the Cyrillic P. You may hear people talk about it being a ratio of 22/7. This is approximate. This number never stops. That means you can't write it as a proper fraction completely. There are ways of writing it as a fraction which are continuously adding more fractions in various places. You can either do them in denominators or next to each other. If you've got time left today, I'd like you to research the history of methods used, or research the history of pi and the accuracy. So you can go back to the Babylonians and the Egyptians. The Greeks got fairly good accurate answers. The techniques they used were slightly different. Babylonians and the Egyptians did pretty much what we've just done. They did it by measurement. The Greeks did it by getting very clever about how shapes fitted inside and outside circles. Then quite a long time it went over to China, and they were doing further accuracies, and they managed to get things a bit more accurate. The big strides started happening in the 1700s and 1800s when completely new techniques to do with something called calculus came along. And then finally the number of digits being calculated started exploding in the 20th century, getting to hundreds and then thousands of decimal places, leading to the current position. And why are they doing it? I'd like you to be able to tell me of millions and billions of decimal places. And why are they doing it? It's important. Why are they calculating pi to that accuracy? Because the accuracy they've got on pi, you could measure the circumference of the galaxy, I think it is, to the nearest hydrogen atom, or even I think it was the diameter of a proton. So that's what I'd like you to do with any extra time when you've done this 5 or 6 values. There is a little bit of preparation I'd like you to do for another lesson, which is take some of the shapes that you've just been measuring, draw the outline onto a piece of paper and make a note of what the shape is. There's a bit of the video following this. So thank you and have a good time. Enjoy it. Try and think what's happening. But we do need some circles for you to test in a few lessons' time. Just before you finish for the day, so you don't have to grab the same things tomorrow, what I'd like you to do in preparation for the next lesson is collect together the items that you can fit onto a piece of A4 paper and trace it. So wherever you did your circumference, trace out the circle so you know how big it was. Things like balls are really awkward to do, but let's give it a go. I'm tilting my pen slightly in so I can get as close to my circumference as I had before, and I'm just going to check it and make sure it agrees with the measurement I made before, which is 17 centimeters across the middle. That's not bad, it came in at 17, so it's not a bad diagram. The reason we're going to do this is we need these tomorrow for our next session for working on area. So I'm going to make a quick note of what it was. This was nightlight. And its diameter was diameter 17 centimeters or 6.5 inches. The distance around the outside, what normally is called a perimeter, but for circles is called the circumference. And I measured those as 53.3 centimeters or 21 inches. So if you could get your items together and record. Sorry, my video's flipped. I haven't worked out how to get the camera to flip round, and I can't do it in the video editing software I need. So try and have a list of and a copy of each of the items that you have done. So you can do them on the same page if you can. So I haven't done the measurements for this, but yeah, you can take the bottle cap, label it, and put your measurements on. If you just want to do the tracings now, it might make today a little longer, but you can take the time off tomorrow and make it a little bit shorter. So we can actually work with the areas. That's why we need these, is we're going to do area as well. We're going to make copies of these circles and then work out how to calculate the area of some of these circles. Okay, let's close that off.